In this video, we will be discussing how to use density in a conversion problem. So our problem states or asks, what is the mass in kilograms of an object whose volume is 2.016 liters and whose density is 1.18 grams per milliliter? This problem includes 3 pieces of information. The question is asking, what is the mass in kilograms? So this piece of information is what we are trying to find. Next, the question gives us the information of volume of 2.016 liters. So this is the given information. The last piece of information that they give us is a hidden conversion factor, which in this case is density, the 1.18 grams per milliliter. Let's create a unit map in order to figure out the answer to this problem. The information that's given to us is the unit liter. So that will be the first part of our unit map. The hidden conversion factor that they give us is grams per milliliter. So the next unit that we need to change our liter into is milliliter. Density is how we are going to relate gram and milliliter. So gram is going to be the unit that we write next, and ultimately the question is asking us for kilograms. So kilograms will be our last conversion factor, or our last unit. Let's create a conversion table for the information. The question gives us the number 2.016 liters. And even if we don't know anything else, if we have the unit of liter on top, that is the unit that must go to the bottom of our conversion table. According to our unit map, we're going to change our unit of liter into milliliter. So this is the information that's going to go above liter. Even if we don't know anything else, if we have the unit milliliter on top, we know that must be the unit that we write on the bottom. According to our unit map, we can relate the idea of milliliter and gram using our density conversion factor. So gram is going to be the unit that we place on top of milliliter. Since the question is ultimately asking us to find kilogram, we will put gram on the bottom and kilogram on the top of our conversion table in order to find the answer to our question. Now we can fill in the numbers into our conversion table. We can put the number 1 with the unit milliliter, and according to our stair step, there are 1 times 10 to the negative 3 liters in 1 milliliter. So that is the number that we're going to write with liter. In this part of our conversion table, we're trying to relate the idea of gram and milliliter, and this corresponds to our density. So there are 1.18 grams for every 1 milliliter. Just as before, we can put the number 1 with our prefix kilo, and according to our stair-step ladder, there are 1 times 10 to the 3 grams for every 1 kilogram. So we'll say 1 times 10 to the 3 grams in 1 kilogram. Now we can plug this number into our calculator to find our answer. Parentheses 2.016 parentheses 2.016 times 1.18 close parentheses divided by 1 times 10 to the negative 3 times 1 times 10 to the third close parentheses equals. So our final answer is 2.37888. Because our original problem included 4 significant figures here and 3 significant figures with our density, our final answer will have 3 significant figures. So the answer becomes 2.38 liters cancels out with liters, milliliters with milliliters, grams with grams, for a final unit of kilograms. So this is our answer.